Alright, ladies and gentlemen, welcome. If you are watching this, then you should have already watched the video notes, so I will not go into as much detail in this video. This will be just more of a review of those video notes. If you have not watched the video notes yet, please make sure you do that. It is video 4 on your Canvas page. So I want to first talk about the difference in the directions. In our directions at the beginning here, it says identify the GCF for the following expressions. In this case, all I want is the greatest common factor. I'm not looking for you to factor it all out. I'm not looking for the monomial and the binomial or trinomial, whatever that is. I'm only looking for the GCF. Compare that to factor completely. This is where I need everything. I want to know what is your GCF, and that becomes the monomial in front, and then I want to know whatever was left over, and that becomes your, in this case, binomial, in this case, binomial, or trinomial, and that's always what's going to be left over. So factor completely, I want everything. If the direction states simply identify the GCF, all I'm looking for is that greatest common factor. So remember, we're looking for the common factor between our terms, all terms in the problem. So in number 1, we have one addition sign that separates this into two sets of terms, or two different terms. I like to do all of my factor trees, get this down to primes. For the numbers, in this case, that gets me 2 times 7. 21 is 3 times 7. But I can also factor my variables down to its primes as well. X to the 4th represents x times x times x times x. And x to the 2nd is x times x. Okay, those are my factor trees down to primes. Your GCF is what is in common, what is being shared in both terms. So I like to kind of mark the text here. They both, as far as the coefficients, have factors of 7. In the first one I'll circle it, in the second one I'll circle it and cross it out. Okay. They also both have an x. I'll circle the first, circle and cross out the second. And they'll both have a second x. They don't both have a third x, so I can't circle anything else. They don't both have a 2 or a 3. I can't circle anything else. I cross those out because I'm not using them. I'm only using them when I circle them one time, so I'll only use them here. What I circled is my GCF, all multiplied together. I circled a 7 times an x times an x. When I multiply all of that together, 7x squared. Okay. The only difference in a problem like number 2 is I have 2 addition or subtraction signs. I circle them, don't cross them out. Those are really important when we have factor completely. And I can separate this into 3 columns because I have 3 terms. But what I do is the same. Factor trees or factor to primes. 6 down to primes is 2 times 3. A squared is a times a. And b to the 5th is b times b times b times b times b. All of this multiplied together gets me back here. Coefficient, only one a, and I have b times b for b squared. 10 is 2 times 5. A to the 3rd is a times a times a, and b to the 4th is b times b times b times b. If we can get those factor trees down correct, finding the GCF is a lot easier. Okay. Now again, when I'm looking for things in common, they have to be in each one of these columns, meaning they have to be factors of every term. But here it was 2 terms, now I have 3 terms. So I need it to be shared in all 3. I have a 2 as a factor in all 3 sections. I circle all 3, but I cross out the ones in the middle and the end terms. My GCF is going to come from the circles in the first term. They don't share a 3 or a 5 because they're not in all of them. Okay. They all have an A. I can circle an A, but only the first and the third have another A. Since the second one doesn't, I cannot circle it. Okay. And then they all have 2 B's. B and B, B and B, cross them out. B and B, cross them out. They don't share any more b's because the middle term doesn't have any other factors. Okay. So what did I circle? 2, an A, and 2b's. 2ab squared is my GCF. Okay. Now the one thing we haven't talked about yet is what's left over. What's left over is going to be equally important as soon as we get to the next set of directions, which say to factor completely. In this one I had a 2 and 2 x's. I had 2x squared left over. Here I only had a 3 left over. Here I had a 3, an a, and a b to the third. In the last term I had a 5, 2 a's, so a squared, and 2 b's, so b squared. Nothing was left over in here. But technically there was something left over, because the one number that we don't necessarily consider a prime number because it's not really prime is 1. It does have a factor of 1 in here, and if everything else cancels, that's important to recognize, because I have to include a 1 as that factor that's left over. Yeah, there is a 1 in here as well, but if I do 5 times 1, I get 5. And there's a 1 in here as well, but if I pull out a 1, it doesn't change anything. So the only time that 1 is really important is when every prime factor is a common factor. Then we have to include that 1 as that factor left over. Okay. So I've already kind of put all the pieces of the puzzle together. Those are all the pieces of the puzzle. Let's go ahead and look at, I will do 2 of these and then pause it and you guys will do the other 2. Okay. So for number 3, it has 2 terms separated by subtraction. Prime factors are 3 here, 3 and 5 here. Variables are z times z and z. So when I look for my GCF, they both have a 3 and they both have a z. That makes my greatest common factor 3z. That is always the monomial we pull out and put in front of our parentheses. This had a subtraction symbol, so I'm going to have a subtraction symbol in here. The leftovers are what goes back into this binomial. It started as a binomial, so the inside the parentheses still needs to be a binomial. The first term had a z left over. Bring my subtraction down. Second term had a 5. This becomes z minus 5. That's factored completely. Okay. Now I'll do number 6 and then I'll have you guys do 4 and 5. 6 I'm only going to do because the only difference is here it's a trinomial. So I have a subtraction and an addition. Doesn't change what I do here. Prime factors are 3x times x times x. 12 becomes 2 times 2 times 3 times x, and 78 becomes 2 times 3 times 13. Remember, that's just going through our factor trees here. Okay, winds up being 2 times 39, and that's 3 times 13 with my 2. Those are my prime factors. Go in here. There's no x's. Common, 3, 3, and 3. I can cross those out. Nothing else is in common. 3 is my GCF. What's left over? X to the third. That's subtraction. 2 times 2 is 4 and an x. Then addition. 2 times 13 is 26. That's what goes in. I started with a trinomial. My parentheses become a trinomial. And we're done. Go ahead, press pause and try 4 and 5, please. Hopefully you ran into this problem. There's nothing in common. They don't have any common factors at all. This is considered a prime polynomial, but instead of calling it a prime polynomial, we might just write it down as factored completely already. It's 21x minus 10. I don't have to do anything. And for number 5, we get 10x squared as the GCF times the quantity of 12x squared plus 5. Those are what was left over. So even though I have a pair of 2's here, it's not about being a pair in one term when we're finding GCF. That's only when we are simplifying square roots. It's about having a pair in 2 terms we have to compare. So the 2's don't pair up in this case because they're not in different terms.